Hi folks, welcome to this introductory presentation for probability. In this first example, we're looking at three different boxes of red, green, and white balls, little candies, and I'm going to pick one out of each of the three boxes. So this is an example of um, with what we call with replacement. So we have three separate boxes, therefore the probabilities won't change. First thing I'm going to do is I'm going to move down here to the bottom and look at some probabilities. So since there are a total of 8, 12, and 4, so we've got 24 total candies in each one. So I'm just going to write a 24 in each of our boxes so that I can see that there are 24 candies there. There are 4 white, so that's going to give me a probability for the white of 1/6. That's 4 over 24. For the red, it's going to be 1/2, 12 out of 24. And for the green, it's going to be 8 out of 24, which is 1/3. That applies to each of the three boxes of candy. So let's take a look at the first example here. It just says all three are red. So part A, if all three are going to be red, then that's going to take our multiplication of the first probability, 1/2, that's the probability of the first one being red, and then multiply that by the second one being red and also the third one being red. So pretty simple, 1/8 is the answer here. You can almost do that in your head, and let's go on to part B. Second one says the first is white and the next two are green. So again, you're just saying the first, you're just writing all these probabilities out. 1/6 is the first one, and then the next two are green, so 1/3, 1/3. So 1/3 here and 1/3. In this case, 1 over 54. Okay, put a circle around that one. Part C, none are green. So in this case, we're looking at, since none of them are green, we're going to combine the reds and the whites. So we're looking at 2/3. In other words, the same thing as not green. So 1/3 for green, 2/3 for not green. So in this case, we're going to say none of them are going to be green if it's 2/3 cubed, or 8 over 27. So actually a pretty good chance that that's going to be the case. And then the last part is at least two are red. So in this case, we could add in this one, we could add two of them being red, uh, and then we could look at the possibility of all three red. So we've already looked at what happens if in number one or part A there all three are red. So we're going to take that 1/8 and add it to exactly two are red. Now in this case, you could have two of them red and the other one non-red. So that would be three possibilities because we don't know which box is going to come from. One of them is red, so that's a 1/2 chance. And then 1/2 and 1/2 is also not red. So that's how that's going to work out. It's going to end up being 3/8 plus 1/8 or 4/8, which is a 50-50 chance. So 1/2 is the answer there. All right, so I hope that I have calculated those properly. Let's move on to the next example. In the second part, this one's a little bit different. This is talking about a 10-question multiple choice test. The answers range from A to D. So, for example, we've seen that this is repetition okay. So first of all, I'm going to put on the top here, repetition is okay. And typically that means something like 4 to the nth power. For example, if there are 10 questions, then there are 4 to the 10th ways to arrange it, etc. So in the probability statement, probability of anything in this case, 1C, in this first problem, the denominator is going to be all the possible situations of multiple choice tests ranging from A to D. So that's going to be 4 to the 10th power. There are a couple things we can do for the numerator. The first thing we see is that if we have um, exactly one C choice, that C choice could come in any of the 10 problems. So I'm going to write down a 10 because each of those, so I don't need to write these down, but just if I had my 10 little slots, the C choice could be at any of those 10 places along the line. So that's the first thing I see. And for every one of those positions, I see that I have 9 positions remaining. So all the rest of these positions are still remaining for each of these guys. So for each one of those, I'm going to have 9 more, and I'm going to multiply that by 3 to the ninth. Now you can see after a moment of thought, you can see why this number is 3, because the choices cannot be a C. They could be an A, a B, or a D, and they could be repeated. So again, we have the same thing. It's this idea of repetition allowed. So the answer there, 10 times 3 to the ninth all over 4 to the 10th. Now I do not have an answer for that because I don't have a calculator with me, but you can imagine that that answer would be um, some decimal. So I'm just going to box that. Okay, so that's the probability of 1C. And then the last problem here is the probability that I select exactly 4B choices. Now the thing about this one is that a B is a B is a B. So I've got a B here, and let's say that I've got a B over here, and I've got another B over here. Now the interesting thing about this is my 4B terms, the order doesn't matter. So this is going to be a combination 10 choose 4. Now that's an interesting one because the 10 choose 4 says that there are 10 choose 4 ways to select 4 B choices out of a total of 10 slots. But remember, for each one of those, I'm going to have 3 to the 6th power, and that's because there were 10 minus the 4, because those were the B choices, is the 6th power. That's the remaining parts. And again, this is over 4 to the 10th power. So as you can see, our counting methods, which really talk about the numerator as the possible choices. So these are um, possible choice. Um, this is the possible ways to get 4 B's, and then our denominator is always going to be the total number of test possibilities. Okay, so this is another tricky little problem there. Okay, so there's a nice little introduction to probability and how we set up those numerators and denominators.